clear understanding of user roles and permissions might be missing, leading to unauthorized access and weak authentication methods. Inadequate logging and auditing of AAA events could also lead to non-compliance issues and possible security threats. And lastly, the absence of a disaster recovery plan could put the entire system at risk during unforeseen events. Now, picture this scenario being applied in various enterprises and projects. For instance, in traditional systems like Radius and Diameter, the AAA servers have served as gatekeepers for years, whereas in emerging systems, the role of the ADLA server is being taken over by innovative solutions such as OpenID Connect and OAuth 2.0, and advanced technologies such as those mentioned above are being incorporated. Today's more advanced platforms deploy comprehensive identity and access management systems such as OME-DM and OME-NGSI, or cloud-based solutions like Google Cloud Identity and Access Management, and Amazon Web Services Identity and Access Management. Then there are companies like Okta and Ping Identity, modernizing the concept of AAA servers and bringing a new level of sophistication and security to gatekeeping. In the world of 5G networks, the AAA server, much like our bouncer, checks the identification of the devices trying to connect, ensuring they are who they claim to be. This process is known as authentication. Various methods such as usernames and passwords, SIM cards, or certificates are used to verify the device's identity. Once the identification is authenticated, the bouncer, or in our case, the AAA server, decides whether the device should be allowed access to the network. This step is called authorization. The AAA server takes into account the device's identity and role to determine the specific services it can access. For instance, a device authorized to make voice calls may not have the clearance to access sensitive corporate data. Now, just as the bouncer keeps an eye on the guest's activities within the restaurant, the AAA server keeps track of the device's network usage. This process is known as accounting. The AAA server generates billing records based on this information. This data is crucial for troubleshooting network issues and billing users for their network usage. To summarize, the AAA server is an essential cog in the wheel of a 5G network. It ensures that only authorized devices gain access to the network and that they access only those services they are authorized to use. This helps maintain the integrity of the network, protecting it from unauthorized access and misuse. In the ever-evolving world of technology, AAA implementation has seen significant changes. Traditional AAA systems, with their centralized nature and static policies, are making way for more dynamic, distributed systems. The emerging ADLA systems, adaptable to a wide range of access control applications, are built on open standards, making them more interoperable. The shift from on-premises deployment to cloud-based deployment has also reduced costs and eased management. In conclusion, the AAA implementation in a 5G network is like the vigilant bouncer at a high-end restaurant, ensuring a safe and secure network experience for all authorized devices. The evolution from traditional to emerging ADLA systems is paving the way for a more flexible, scalable, and cost-effective network management.